This section introduces concepts related to securing storage. Storing large quantities of data in a centralized repository makes security a key element of your architecture planning process. With Amazon S3 at the core of your data lake solution, several robust security features and capabilities are intrinsic to the service and available to you. You can use these capabilities to help protect your data from both internal and external threats. The durability of Amazon S3, combined with protections against malicious deletions and corruption, help to provide a high lake grows, at a high level of data protection for your data lake. As your data lake grows, the need for fine-grained security controls to secure your data's processing and lifecycle grows. You can combine the inherent security features of Amazon S3 with other AWS services, such as IAM, AWS Key Management Service or AWS KMS, Amazon Cognito, and Amazon API Gateway. The capabilities of these services can help you to ensure that your S3 data lake meets stringent data security, compliance, privacy, and protection requirements. Access policy options are a good way to manage access to your S3 resources. Access policy options are broadly categorized as resource-based and user policies, and they can help you provide access to various AWS accounts and users. Bucket policies and access control lists, or ACLs, are two resource-based policies that are available to you to manage access to your buckets and objects. These policy types are highly customizable, and you can secure your S3 resources down to the object level. While resource-based policies are an excellent choice to secure your data lake resources, AWS recommends using user policies for most data lake environments. With user policies, you can assign permissions through user roles and permissions to provide access to the data processing and analytics services and tools that your data lake users will use. When you implement user policies along with IAM, you can create IAM users, groups, and roles in accounts, and then attach access policies to them that grant access to the AWS resources that make up your data lake. By using encryption keys to encrypt and decrypt data assets, you can prevent users from inadvertently or maliciously gaining access to your data assets. With Amazon S3 at the core of your data lake, multiple server-side and client-side encryption options are available. You can use AWS KMS for centralized control over encryption keys and audit the usage of those keys through the integration of AWS KMS with Amazon CloudWatch. Finally, you can combine the capabilities of services such as API Gateway, Amazon Cognito, and IAM to create a marketplace model where users can check in and check out data lake assets. In Amazon S3, you can use object tags to categorize and manage your S3 data assets. You can use object tags in conjunction with IAM to enable fine-grained access permissions. You can also use tags to manage S3 data lifecycle policies. Finally, you can combine object tags with CloudWatch metrics and AWS CloudTrail logs to monitor and audit data based on specific data asset tag filters. In addition to the components and features of lake formation that were discussed earlier in this module, you can centrally govern your data lake by defining granular data access policies to the metadata and data through grant or revoke permission models. The integration of lake formation and IAM provides this capability, and you can define both metadata access control and underlying data access control. You can grant access to named resources in your data lake by using tag-based access control, or TBAC, which is the recommended method because of its ability to simplify access control while managing a large number of data catalog resources and principals. Amazon Redshift handles database security separately from the security of the service itself. While access to Amazon Redshift is managed through identity and access management measures, there are additional features that are included to manage database security. The student guide for this slide includes additional information about these features. Amazon Redshift uses third-party auditors to assess security and compliance. Therefore, using Amazon Redshift can help you to meet compliance and security requirements for handling sensitive data. For monitoring and alerting, Amazon Redshift integrates with CloudWatch, CloudTrail, and AWS Security Hub to provide increased oversight and visibility over the service and its resources. Here are a few key points to summarize this section. With Amazon S3 as the core of your data lake, the security features that are inherent to the service are a central part of your data lake architecture. Resource-based and user access policies are highly customizable ways to provide or restrict access to resources in your data lake. Data lakes that are built on AWS rely on server-side and client-side encryption. Amazon Redshift handles the security of the service and the security of its databases as two distinct functions. This allows for greater security of the data that is stored within. This section summarizes what you've learned and brings the module to a close. This module defined the storage types that are found in a modern data architecture. You also learn to distinguish between the storage types and select the option that matches the requirements and constraints of your use case. And finally, you learned about secure storage practices for cloud-based data. Here is the sample exam question for this module. A data engineer is designing an infrastructure and wants users to be able to query data directly from files in the company's data lake, which is built on Amazon S3. Which service feature would enable this capability? What are the key parts of this question? The question mentions the need to query data directly from files stored in a data lake that's been built using Amazon S3. Now let's look at the answer choices. A, AWS Lake Formation, B, Amazon Redshift Spectrum, C, AWS Glue Crawlers, and D, Amazon Neptune Graph Queries. Based on the keywords that were identified in the question, which answer is correct? We'll pause a few seconds before discussing the correct answer. If you need more time to consider the answer choices, pause the video. The correct answer is B. Choice A, AWS Lake Formation, is incorrect. Lake Formation is a service, not a specific service feature. Choice C, AWS Glue Crawlers, is incorrect. Crawlers are used to populate the AWS Glue data catalog with tables. They are not used to perform queries. Choice D, Amazon Neptune Graph Queries, is incorrect. Data from Amazon S3 would first need to be loaded into Neptune and couldn't be queried directly from the data lake. With Redshift Spectrum, you can extend your analytics beyond the data that is stored on local disks and perform queries on data stored in Amazon S3. The correct answer is B. That concludes this module. The Content Resources page of your course includes links to additional resources that are related to this module. Thanks for watching.
Welcome to the Processing Big Data module. This introduction section describes the content of this module. This module builds on the ingestion and storage elements of the big data pipeline that previous modules covered. This module highlights the processing frameworks that are integral to the AWS services that support big data processing in the AWS cloud. The objectives of this module are presented across multiple sections, each with its own video. The module wraps up with a sample exam question.